Yeah, welcome also from my side. So today I'm going to talk about Autosars role in context of a vehicle OS. Might some of you think, well, the role is defined, but we will see there might be use cases which are not clear right from the beginning, but which absolutely make sense. So how does it, or how is the presentation structured? I will talk a little bit about the SDV and the vehicle OS, just 2 slides as an introduction. Then I switch over to ROS because I use ROS 2 as an example what Autosars can do besides hosting applications. Well, that's kind of a teaser. So it's about the third point, the integration of ROS and adaptive, how that could work together. And at the end, there's a summary. So in context of the EE system, we have basically 3 enablers for the software-defined vehicle. At least that's how we define it. The first one is the EE architecture itself, like decoupling compute units, HPCs, from sensor and actuator units. So having the zonal HPC architecture is enabler number 1. Enabler number 2 is high-performance microcontrollers and microprocessors. Just because we need spare computing resources. So if we pack all the software that we have a CPU load of 80% right from the beginning, that's not going to work for a software-defined vehicle because you need some spare, you need powerful processors and controllers. Both of them, I would say, check because both of them are available and currently being worked on. The third one now is what we call vehicle OS. So basically a software platform and ecosystem to manage the complexity, the software complexity entering the HPC units. So if we have a look to the software-defined vehicle architecture, basically we are shifting hardware complexity or EE system complexity and move that to the centralized units. So therefore, it's not a surprise that the software complexity in these units is increasing, and we need a solution for that. And this is what we call vehicle OS. And to be a little bit more precise, just a definition we came up with. For vehicle OS by itself, I already gave it a little. So like it's a software platform and ecosystem for all vehicle services and domains. So we are not differentiating between there's a vehicle OS only for IVI, so in-vehicle infotainment, or there's only a OS for ADAS. But the platform software is covering everything. And it consists of 2 principal elements. So it's the base layer, so we call it base layer. It's the actual runtime software, so the embedded software running on the ECUs. And as you can see, it's a little teaser, so it's not only in the vehicle, it's also in the cloud or in the backend. And the second component is what we call software factory. That's basically the workflow, because you can have the best embedded software ever. If it's not possible to make it use in a user or to use it in a user-friendly way, it doesn't work either. Because you need to manage the complexity so that the end user is able to make or to get out of the embedded software the best he can. So we have a short equation. So vehicle OS is base layer and software factory, but it's nothing worth without collaboration. And this is what we have heard the last 2 days several times. Again, you can have the best base layer and the best software factory, but no company will master it on its own. So you need that kind of collaborative setup in the base layer as well as in the software factory. Now a quick deep dive into the base layer, just to give you an idea what we are thinking or how we are thinking of that software platform and ecosystem from an embedded perspective. Left-hand side in-vehicle, right-hand side back-end. And I will start, I have now columns. And the first column is the classical world where we are coming from. We are coming from the microcontroller world. Like, let's say 5 to 10 years ago, it was all about microcontrollers. And there, the red parts in the middle is the contribution of Autosars. And don't be confused. So the operating system is, of course, part of Autosars Classic, but it's just of symmetry reasons, because we will see if we go to the right that there's a difference. Then, next to the microcontroller, classically, we have HSMs. They are served or can be served in a similar way. And this shall be indicated by the orange part. So orange means it's not natively in the focus of Autosars, but still there's a contribution of Autosars because the firmware, the HSM firmware, can reuse a lot of things Autosars has defined. And for switches, Ethernet switches, it's basically the same. So like You can, of course, do bare metal software implementations, but hey, if we have an Autosar switch drivers, if we have their shapers, like for TSN and ABB networks, it's exactly the same we need in switches as well. So why reinventing the wheel? So you can see here, the original intention of Autosar was the classical microcontroller, but it now spreads towards adjacent use cases like HSM and switches. The new world started few years ago when we are talking about microprocessors in a vehicle, about HPCs nowadays specifically. We can see, okay, it's getting more diverse. We have an operating system, which is now here clearly separated. So we are into different POSIX-based operating systems. We also have heard several times these days container runtime on top of it. And then we have workloads containerized running on this engine. And within that container, we have Autosar classic or adaptive, so primarily, of course, adaptive, but still there might be use cases to even deploy classic systems on an HPC. But let's talk about that. That's adaptive now. Then we have the middleware layer here, again defined by Autosar, hosting the applications. I will now, the next two at the same point in time. So it's, again, our idea, our intention to say, well, we have a HPC, but we cannot serve all the application use cases by the same software because there are different workflows, different life cycles, different development environments, different SDKs even covering the ADAS segment, which is quite special, and covering the in-vehicle infotainment segment, which is also quite special. So at the end, we end up with three distinct, let's call it solutions, like we have a separate, or main domains. So we have the domain in-vehicle infotainment, we have the domain ADAS, and we have the domain general purpose, or let's call it rest of the vehicle, like powertrains, chassis, body, things like that. And for two of them, so like for ADAS, adaptive is well suited as a middleware, but I will come to that on a later point in time in the presentation, back to that thing. For IVI, I think we all agree that maybe Autosar is not the middleware you are going to use for Android app development, for example, but still, Autosar can contribute here in order to feed and in order to attach the vehicle infrastructure, the vehicle ecosystem to existing ones like Android, for example. And just as a side note, it's not part of the talk today, but on the back-end side, it's quite similar, at least from an idea. So it's not the native intention to run an Autosar adaptive on the back-end side, but still there might be a use case you want to deploy adaptive applications in the back-end infrastructure. If we are thinking about containerized development, so deploy the same container on backend as well as on the HPC, then this comes into the picture as well. Second point now, software factory. Oh, one step back. You can see all the colored blocks are now the contributions of Autosar. Red, again, the original intention. Orange, spreading, reusing things being defined. Same color coding now for the software factory for the workflow. And to keep it simple, I know the workflow in reality look far more complex, but to get the idea, I reduced it to there's an application development workflow, and it's covered by the system design workflow. And of course, those workflows are not specified by Autosar. There's not a blueprint on how to do this kind of things exactly. However, the exchange formats, and this is the reason why the arrow between the two things is red, this is defined by Autosar. This is a main contribution besides the pure embedded software. So coming back, we have the application development workflow, and we think of that in an agile environment. We think about hourly executions of that workflow. So it's not like I'm starting developing an app, and in 2 months in time, the app is finished. But this workflow is really, it's kind of continuously worked on, and it's on an hourly basis. That's true for the application development. For the base software development, this maybe looks a little different. So we are here not on an hourly basis, but maybe on a weekly or daily basis. But still, we are creating artifacts, single artifacts. And then in the next step, we have the ECU integration workflow, like bringing the artifacts together to have an integration, a binary you can deploy on an ECU. If you have the single binary of an ECU, again, the next step is get it not on an ECU level, but get it on a vehicle level, and at the very end, you just deploy it on the vehicles. And you can see this is kind of, we think about that as a chain of workflows, and all the orange framed workflows are supported by Autosar, or at least there are some contributions, some ideas of Autosar in there. So this is like, if we would just see Autosar and the ecosystem, this is how we see it right now. Now, well, as mentioned, so Autosar is not everything. There are ecosystems beside we have to take care about. I mean, this kind of the message of the whole conference, right? So I take just ROS2 now as an example, and how we can kind of combine those, and maybe reason a little why this could be meaningful. So just as a brief introduction, what is ROS2? It's a robot operating system. And it consists of libraries, more or less, and a tool set supporting you in develop really robot applications with arms and positioning and things like that. And the idea is to reuse that kind of ecosystem for vehicle application development, especially in the ADAS domain. It has nodes, so different terminology than Autosar, but the nodes are basically the applications. It's supported by an own middleware. So you have a small library, you are linking to your applications, making all the functions available to the application, so provided by ROS, available to the applications. And then you have the middleware abstracting the communication, and for communication it's foreseen to have either DDS or an IPC, like an inter-process communication. And it relies on a third-party operating system, may it be Linux, may it be QNX, or may it be any other POSIX-like system. Having said that, so I would like to start with a quick comparison. Okay, we have Autosar Adaptive on the one hand side and ROS2 on the other hand side, and you may ask yourself, hey, why do we need two ecosystems solving the same problem? But they have some fundamentally different properties, let's say. And I will start with more or less the negative side of Autosar, but don't worry, there's also a positive side. So ROS has a very low entry hurdle. So if you want to start, if you want to write a ROS application like perception or like trajectory planning or something like that, you can really start very easy. You find tons of material, of documentation, examples. It's well known in the educational environments. So large community, large ecosystem. Compared to Autosar, well, also a kind of topic of the conference, Autosar is rather closed right now. It has a rather high entry hurdle because we have this kind of AR XMLs we have to take care about, all these configuration steps we need to take. And to be honest, it's also not so well documented in terms of examples. You cannot just play around with it. I mean, we have the Autosar Adaptive Demonstrator, right? And you can play around with that. For Classic, we are maybe missing something. But in general, if I compare that to ROS, it's really a kind of big difference. And now the big but, you can turn that now around if it comes to more serious things, let's say. If it comes to system methodology and templates, so if I want to bring a car on the road, at the very end, I need to understand it, I need a model for it. Otherwise, there's driving something around you don't understand anymore. This is offered by Autosar, it's not offered by ROS. ROS is totally open, bottom up, everybody can do whatever he likes to do. Second, safety and security. Nate, this is the DNA of Autosar, right? It's not a DNA of ROS, but it's a DNA of Autosar. And the same holds true for the automotive ecosystem and the automotive protocols. So we are talking about network management, about diagnostics, about some IP, about all these things we have learned and loved in the past. They are available in the Autosar ecosystem, but not in the ROS ecosystem. And if you now have a look to that, maybe there's the question, hey, how about combining both? So we have two ecosystems, two different set of properties. Why not somehow bring them together? And it's specifically what we are thinking about, hey, taking ROS as a fast entry, a fast going forward in making prototypes, for example. And then in later point in time, switching to Autosar when it really comes to safety and security concerns and to functional requirements you have to fulfill and you have to maintain over a large period in time. So next question, how about integrating ROS nodes on top of Autosar Adaptive? And this is the theory I want to follow up now in the next two slides. So the integration of ROS nodes on Autosar Adaptive. And this is quite interesting. When we started that kind of activity, we had a look on, okay, what is provided by ROS? what is provided by Autosar. And this is just a subset, but I think most of you are familiar with the communication paradigms. So if we have a look to the Autosar adaptive communication, it's ARA-COM. As a communication protocol, we have either SUMIP or DDS. And usually we are talking about methods, events, and fields. This terminology is derived from the SUMIP specification. And we have something on the left-hand side, execution management and platform health management, to provide a principal runtime which can execute applications. If we compare that to ROS2, the terminology is different, but it's possible to map that quite smoothly. Like what we call services in ROS2, it's methods in Autosar. What we call messages in ROS2, it's events in Autosar. And I can do that quite similar for all the other blocks. And this was the idea, okay, well, then just let's take an adapter, combining or making use of the ROS API at the top level and making use of the Autosar ARA APIs on the lower end, and have that generated adapter in between. And mapping that to the architecture picture we have seen before, it's not changing much. So like there's a laser, we are having here the adapter, which is now, you can call it a plugin into adaptive. And you can now put regular adaptive applications and ROS nodes next to each other on an application level. Well, this is only half of the story, right? Because we have been talking about the embedded software, and now we need to talk about the workflow as well, because if I have two workflows and they don't match, not a good idea. So how about the workflow? The workflow in ROS is, as said, this is one key asset of ROS because it's quite fast. You have all this kind of ecosystem and tools available, most of them open source. So to generate a ROS node, you can make use of the ecosystem like the visualization tool, like a data logging and replay tool, like the build environment, and basically you're coming from a source via a GCC compiler to an executable. How is that mapping to what we need or what we have in Autosar? Well, first, we transfer the ROS environment or the description, because in ROS there still is description. So we have message and service files, because every developer of a ROS node has somehow to explain what kind of services he's offering and what kind of services he's consuming. So these kind of files are available, and we can just take them and transfer that into a general system design. So we import bottom-up approach. Every developer is doing something, generating the files, importing it into a generic system model. And next step, okay, if we have that kind of generic system model, then we can export again the ARXML we need for Autosar. So it's more or less a round trip. You can see that bottom-up or top-down. So this is also the reason why we have here a bidirectional arrow. The system model is there. You can either feed it bottom-up or the system model can feed top-down. So we are coming to the Autosar adaptive ecosystem with this ARA generator, having a CMake environment, having Autosar adaptive with the ROS adapter on top of, and then we can place the ROS2 nodes there. And if I now transfer that again to the picture we have seen before, how does it map to these principal workflow steps? Quite smoothly. You get a new application development workflow. This is next to the Autosar application development workflow. So at the end, the message is it doesn't matter whether you develop applications according to the intended Autosar workflow for the native apps, or you develop ROS nodes according to the ROS workflow. You're ending up with executables, with binaries you can deploy on an ECU. And that means the artifacts, the artifacts generated here, they are just fed into the ECU integration workflow as an input. You bring everything together, and you get an executable indicated here with the small green boxes, now a combination of Autosar and ROS applications, so to speak. And with that, I'm already at a summary. So Autosar, the main message is it's a very important and very big player in context of a vehicle OS. It's providing specifications for classic, for adaptive, the vehicle API or automotive API we have heard today as well, for embedded software, and not to forget about the workflow. I think that's one of the key assets of Autosar, defining a methodology and a workflow, or artifacts you can use to combine it and to establish the workflow based on those artifacts. And now we are at the point of the use case of Autosar, which might not be intuitive at the beginning. So usually if we are talking about Autosar, and especially Autosar Adaptive, it's about having a middleware you can put applications on top of. That's true, that's one major use case, but there's another use case as well. Autosar is the only ecosystem which is connected and fully integrated into the existing automotive ecosystems with all the protocols and all the requirements we have put in there for the last 20 years. But now a little, the downside of the story, right? So it's a really important role, but our environment is changing. So this is not just given that it stays the same. So there's the message I want to play, so let's work together that Autosar plays that important role we have right now also in the future. So thank you for listening.